Hello friends, I, BHATIA, welcome you to my YouTube channel Maths DNA from Origin to Infinity. In the first lecture, we discussed about some properties of symmetric matrices and skew-symmetric matrices. In this lecture, we are going to discuss 10 questions based on symmetric matrices and skew-symmetric matrices asked in competitive exams like NET, GATE, NBHM and IIT-JAM. So let us begin. The first question is D is equals to R belongs to M3R where R transpose is equals to minus R and summation I running from 1 to 3 A1I is equals to 0. Then what is the dimension of D? This question was asked in CSIR-NET and also GATE examination. The options are A1, B2, C3 and D4. You can pause the video over here and try it by yourself once. Now let us solve it. Firstly, it is given to us that R is skew-symmetric matrix because R transpose is equals to minus R, and so the diagonal elements are 0 and the elements above the diagonal are negative of the below diagonal are same. Now how does this happen? Also, the dimension of skew-symmetric matrices of order n cross n is n square minus n by 2. We all know it. Now suppose we are taking a skew-symmetric matrix with diagonal entries as 0 and above the diagonal entries are a1, a2 and so on, then below the diagonal entries will be their negatives. Now it is given that the matrix is skew-symmetric, so aij is equals to minus aji. Now if we consider the diagonal elements, that is a11 is equals to minus a11, this clearly implies that 2a11 is equals to 0, which implies that a11 is 0. So we get all the diagonal entries as 0. Further, let us again consider the same matrix and we need to find its dimension. Now here we can clearly see that in the first row, that is 0, a1 up to an minus 1, there are n minus 1 entries that are independent. Similarly, in the second row, there are n minus 2 entries that are independent, and in the n minus 1th row, there is only one entry that is independent, and in the nth row, no entry is independent because all the entries are dependent. So here we get total entries as 1 plus 2 up to n minus 1, and we know that sum of first n minus 1 natural numbers is n into n minus 1 by 2. This gives us our dimension of the skew-symmetric matrix R, that is n square minus n upon 2. Now we need to find the dimension of D, that is R belongs to M3R where RT is equals to minus R and summation I running from 1 to 3 a1i is equals to 0. Here it means that the sum of the first row is also 0. So let us construct a matrix whose first row is 0. It is a skew-symmetric matrix, so diagonal elements are to be 0, and suppose the one element is A, then the other element has to be minus A and the remaining is B. Here we can clearly see that dimension is 2 because there are two independent entries A and B. But using the formula we can also derive it as 2, that is nothing but dimension of D is equal to dimension of skew-symmetric matrix minus 1. This 1 is nothing but the summation of the first row is 0, that is n square minus n by 2 minus 1, and here n is 3, so we get 3 square minus 3 by 2 minus 1, that is equals to 2. Hence the correct answer is option B. Moving on to our next question. It is the dimension of vector space of all 3 cross 3 real symmetric matrices is. This question was asked in GATE and NBHM examination. The options are A3, B9, C6 and D4. You can again pause the video over here and try it by yourself once. Now let us solve it. It is given that the vector space is of 3 cross 3 real symmetric matrices, and we know the dimension of symmetric matrices of order n cross n matrix is nothing but n square plus n by 2, but we need to derive it. Also, we know that the matrix is symmetric, then Aij is equals to Aji. So let us draw a matrix that is symmetric. Here, the diagonal entries are A11, A22 up to ANN, and above the diagonal, the entries are A12 up to A1n and so on. Then, as Aij is equals to Aji, we get below the diagonal entries as again A12, A23 and so on. Solving this, we get that from here, the first row has n entries as independent, A11, A12 up to A1n. In the second row, there are n-1 entries which are independent. And in the n-1th row, there are only 2 entries that are independent. And in the last row, that is nth row, only 1 entry is independent. That is nothing but A and n. So here we get the total entries to be 1 plus 2 plus 3 up to n. And we know that sum of first n natural numbers is n into n plus 1 by 2. That is equals to n square plus n by 2. And here n is 3. So the dimension is 3 square plus 3 by 2. That is equals to 6. Hence the correct answer is option C, and the dimension of symmetric matrices of order 3 cross 3 is 6. Moving on to our next question. If a 3 cross 3 real symmetric matrix has an eigenvalue 3i, then one of the remaining eigenvalue is. This question was asked in GATE and CSIR-NET examination. The options are A 1 by 3i, B 1 by minus 3i, C 0 and D 1. You can pause the video over here and try it by yourself once. Now let us solve it. We will use a result for this. The result is eigenvalues of real skew-symmetric matrices are either 0 or purely imaginary. Now here one eigenvalue is given to us as 3i, then the remaining 2 eigenvalues will be minus 3i and 0. As we know, complex eigenvalues are in pairs, but there is no 3i, minus 3i in the option, so the remaining eigenvalue is 0, and therefore the correct answer is again option C. A simple one. Now moving on to our fourth question. The dimension of vector space V is equals to Aij of n cross n order, where Aij belongs to C, the set of complex numbers, and Aij is equals to minus Aji over the field R is. This question was asked in GATE and NBHM examination. The options are A n square, B n square minus n by 2, C n square minus 1 and D 2n square. You can pause the video over here and try it by yourself once. Now let us solve it. In the question, it is given to us that A is equals to Aij, where Aij belongs to C, the set of complex numbers, and Aij is equals to minus Aji. Now this is nothing but a skew-symmetric matrix. And also the vector space V is over the field of R, the set of real numbers. So we know that dimension of real skew-symmetric matrices is n square minus n by 2. And from here we get that our correct answer is option B. So you might be seeing that if you know the results and the properties, then it becomes very easy for you to solve any question within just 1 minute. Let us move on. The fifth question is the dimension of vector space of all symmetric matrices of order n with real entries and trace is 0. This is a very important question, as this was asked in CSIR-NET and NBHM examination recently. The options are A n square minus 1, B n square plus n by 2, C n square plus n, and D n square plus n by 2 minus 1. You can pause the video over here and try it by yourself once. Now let us solve it. It is given to us that V is a vector space of all symmetric matrices of order n with real entries and trace 0. We also know that dimension of real symmetric matrices is nothing but n square plus n by 2. But here it is also given to us that trace is 0, which means that dimension of V will be n square plus n by 2 minus 1. This one element is the element that is dependent, that is trace is 0. So we get the correct answer as option D. Moving on to our next question, question 6. The dimension of the vector space of all symmetric matrices of order n with real entries in trace 0 and A11 is equals to 0. This question is similar to the previous one, but here one more condition is added to the question, that is A11. The first row and first element is also 0. And this question was asked in CSIR-NET examination. The options were A. n square minus 2, B. n square plus n by 2 minus 1, C. n square plus n minus 2, and D. n square plus n minus 4 by 2. You can pause the video over here and try it by yourself once. Now let us solve it. As we did in the previous question, it is given to us that the V is a vector space of all symmetric matrices of order n with real entries, and trace is 0, and also A11 is equals to 0. We know that dimension of real symmetric matrices is nothing but n square plus n by 2. Also, the trace is 0 and A11, that is the first row and the first column element, is also 0. This gives us that dimension of V will be n square plus n by 2 minus 1, that is when trace is 0, and again minus 1, that is the first element of the first row and first column. This gives us the value that dimension of V is equals to n square plus n by 2 minus 2, which on simplification gives us n square plus n minus 4 by 2. Hence the correct answer over here is option D. So you can see that once you know the properties and formulas, it becomes very easy for you to solve any question. Moving on to our next question, question 7. Let n be a positive integer and let MNR be a space of all n cross n matrices. If T, a linear transformation from MNR to MNR, is a linear transformation such that T of A is equals to 0 whenever A is symmetric matrix or skew-symmetric matrix, then rank of T is. This question was asked in CSIR-NET and GATE examination, and the options are A. n square minus n by 2, B. n square plus n by 2, C. 0, and D. 1. This is a very important question and I would recommend you to note it down. You can pause the video first over here and try it by yourself once and check whether are you able to solve it or not. I hope you might have solved it. Now let us solve the question by using the property that every square matrix A can be written as sum of symmetric and skew-symmetric matrices. That is, let A is a square matrix, then A plus A transpose by 2 plus A minus A transpose by 2, where A plus A transpose by 2 is symmetric matrix and A minus A transpose by 2 is skew-symmetric matrix. If you are unaware of such results, then watch my first video on the properties of skew-symmetric and symmetric matrices. It is up there in the I tab bar. Now using rank nullity theorem, that is rank of T plus nullity of T is equals to dimension of V. Here we will find the nullity of T, that is dimension of kernel of T. Now why are we finding the nullity of T? Because in the question it is given to us that T of A is 0, and we know kernel of T is equals to A belongs to MNR whenever T of A is equals to 0. Now from the above brackets, that is T of A is equals to T of A plus A transpose by 2 plus A minus A transpose by 2, that is equals to T of A plus A transpose by 2 plus T of A minus A transpose by 2, which is equals to 0. Now this is already given to us in the question, which gives us that T maps all the symmetric and skew-symmetric matrices to 0, and thus the dimension of kernel of T is MNR. From here and from rank nullity theorem, we get that then the rank of T has to be 0, because rank of T plus nullity of T is equals to dimension of V. The dimension of V is MNR and the dimension of kernel of T is also MNR. Then we get rank of T is equals to 0, and therefore the correct answer is option C. Moving on to our 8th question. Let A be a real symmetric matrix then we can conclude that now this question was asked in part C of CSIR-NET examination. The options are A does not have 0 as an eigenvalue, B, all eigenvalues of A are real, C, if A inverse exists, then A inverse is real and symmetric, and D, A has at least one positive eigenvalue. I would recommend you to solve it first and then verify your answer with our solution. So let us solve it. For option A, it says that A does not have 0 as an eigenvalue. Now let's take a matrix A is equals to 0, that is a 0 matrix. Then all the eigenvalues of A are 0 and it is symmetric also. So option A is not correct as it says it does not have 0 as an eigenvalue. Option B, all eigenvalues of A are real. Now this is correct as eigenvalues of real symmetric matrices are real. So option B is correct. Moving on to our next option, that is if A inverse exists, then A inverse is real and symmetric. We need to think on it. Firstly, if A is symmetric, it implies that A is equals to A transpose. Now they say that A inverse exists, so we get A inverse is equals to A transpose whole inverse, which implies that A inverse is equals to A inverse transpose. And we know that a matrix is symmetric if A is equals to A transpose, then here A inverse is equals to A inverse transpose, which implies that A inverse is symmetric, and therefore option C is also correct. And the last option, D, A has at least one positive eigenvalue. Now this is incorrect because from option A we get that A has 0 as an eigenvalue, which is not positive. So the correct answers are option B and option C. A simple question. Now moving on to our ninth question. Let A be a real symmetric matrix and B is equals to I plus IA, where I square is equals to -1. Then this question was asked in part C CSIR-NET examination. This is a very important question, and the options were B is invertible if and only if A is invertible, B, all eigenvalues of B are necessarily real, C, B minus I is necessarily invertible, and D, B is necessarily invertible. You can pause the video over here and try it by yourself once. Now let us verify it. Option A says that B is invertible if and only if A is invertible, and option C says B minus I is necessarily invertible. Now let us take A is equals to a 0 matrix. This gives us B is equals to identity matrix because B was I plus IA. Now if A is 0, then B has to be identity matrix. Now here option A and C both are incorrect from this assumption, from this counter example, because if here A is not invertible but still B is invertible because B is identity matrix, and B minus A is not invertible, whereas in option C it says that B minus I is necessarily invertible. This gives us a counter example for our option A and option C. Now moving on to our next option, that is option B. It says that all eigenvalues of B are necessarily real. Now suppose A is equals to I, the identity matrix, then we get B is equals to 1 plus I with I identity matrix, and all the eigenvalues here are complex. So option B is also not correct because option B says that all the eigenvalues are necessarily real, but we get complex eigenvalues. Therefore B is not correct. And now option D says B is necessarily invertible. Now if all the three options are incorrect, then the remaining four has to be correct, but we will still prove it so that we are good at it. It is given to us that eigenvalues of real symmetric matrices are always real, and so the eigenvalue of B, that is equals to 1 plus I lambda, will never be equals to 0 for any real lambda, that is eigenvalue, and so B is necessarily invertible, and therefore option D is correct. Now moving on to
our last question, that is eigenvalues of skew-symmetric matrices are. This question was asked in 3 examinations, CSIR-NET, GATE and NBHM, and the options are always 0, B either 0 or purely imaginary, C always purely imaginary, and D always real. Now you can pause the video over here and try it by yourself once. Now let us solve it. This is nothing but a result, that is eigenvalues of skew-symmetric matrices are either 0 or purely imaginary, and therefore the correct answer is option B. So you might have noticed in all the 10 questions that if you know the results and properties of symmetric and skew-symmetric matrices, then it becomes very easy for you to solve any question within just a minute or less than that. So I would recommend you to go through the results and properties on daily basis so that you don't forget them, and try to find more examples on each of the property and each of the matrices. I will also provide you more properties on more types of matrices and with more examples. And yes, we have introduced 2 improvement series with a demo improvement series to practice more and more. The demo improvement series is approached by 95% of students. The first improvement series was approached by 91% of students, and the second was approached by 89%. In the improvement series 1, which solutions we are providing it, it has topics like linear algebra, real analysis and complex analysis. In the second improvement series, we cover real analysis again, complex analysis and abstract algebra. If you want any of them, it is given in the description. The link of this is given in the description box. And yes, we have also introduced improvement papers with solution for CSIR-NET JRF. It is found that students or candidates are comfortable with a particular topic, but they are not comfortable in solving a complete paper. Keeping that in mind, we have introduced a practice papers, or you can say improvement papers. These papers will help you get better on daily basis, and we are also having them in 3 different levels, that is easy, medium and hard. So you can select level as per your convenience. The link of the papers is also provided in the description box. And be a member of our social club. Check out more than 140 videos on our YouTube channel and get a complete study material on our Telegram channel.